Okay, this is problem number 4 from the review. We've got 3 radar sets operating independently, and that's important. And they'll each detect an aircraft entering some airspace with a probability of 98%. And our variable, a random discrete variable y, is the number of radar sets that will detect the aircraft out of the 3, right? So find the theoretical mean and variance of this random variable. So our possible values for y are 0, 1, and 2, but, 0, 1, 2, and 3, excuse me. But what I want you to notice is because they're operating independently and they each have the identical probability of 0.98, well, we start to realize that this is a binomial situation, right? And again, that's something that you want to be able to sort of get good at, recognizing we've got 2 outcomes, either the radar set detects the aircraft or it doesn't, and because we have an unchanging probability of success of 0.98, that fits our criterion for a binomial situation. So looking back at the answers here, we can see that in number 4, all we have to do once we realize it's a binomial situation is apply our formulas for the mean and the variance. Okay, so we know that the mean in a binomial distribution is just the number of trials times the probability of success. The trials in this case are the number of radar sets that we're using to detect the aircraft, which is 3. 3 times 0.98 is 2.94. Okay, so there's our expected value. The variance, we have the standard deviation being the square root of this expression here, np times 1 minus p, so the variance is just that same expression without the square root. So we've got the mean times 1 minus p, and that gives us 0.588. So that's pretty simple, and so it's important that you are able to recognize binomial situations so that you can save yourself some work. Had you done this with a table of probabilities like we did in number 3 or like number 5 you see here, you still would have gotten it correct, assuming that you used the correct probabilities in each row, but it would have taken more time. So just be mindful of that and think about the situation that you're working with and decide whether or not it's binomial. Again, don't try to apply this if it's not a binomial situation. We know it's binomial because the probability of success is an unchanging 0.98 regardless of which trial we're on, or whether or not the previous trial was a success. So there you go.